Okay, so the first video I made to review for the final went over an hour, so my software just kind of stopped after that recording. So I'm gonna, I think I left us just with all things hypothesis testing left. So I'll try to use the quiz me buttons. They're a little bit more time consuming, but maybe I can move us through that quickly. The practice I like better because they can give you some help with them, but my quiz me button is weighted out for this. So just some conceptual questions on hypothesis testing, right? What are the two types of hypothesis used? How are they related? We just have the null hypothesis and the alternate hypothesis. That is it. Those are only two hypotheses that we have, okay? How are they related? They're complements to each other, right? So they have to add up to 1. Like one is going to say, you know, mean is less than 5, and the other one's going to say greater than or equal to 5. So they have to be completely complementary. There can't be any like overlap where you wouldn't be something that wouldn't be included in one of those two. So what happens when we run the hypothesis test? We only do one of two things. We either reject the null hypothesis, okay, or we fail to reject the null hypothesis. That's it. I know failing to reject sounds like we're accepting the null hypothesis if we fail to reject it, but we either reject it or we fail to reject it. Those are the only two ways that we want to look at articulating that. Okay? Determine whether a statement is true or false. Okay? In a hypothesis, you assume the alternative hypothesis is true. That's false. We are going to assume that the null hypothesis is true. That's always our null assumption. Okay? And remember, with the quiz me button, it's just a little excessive. That's why I want to try to do some of the practice problems. But it gives you a lot more questions than you're actually going to see on the test. So if you get through the review, you'll be really, really in good shape for test 3 or the final. Determine whether the statement is true or false. If it's false, we rewrite it. If you decide to reject the null hypothesis, then you can support the alternate hypothesis, right? So yeah, when we reject the null hypothesis, it's that we have significant evidence in favor of that alternate hypothesis. So we would say that that's a true statement. Okay. A large p-value in a test will favor a rejection of the null hypothesis. That is false, right? Remember, if the p-value is low, the null must go, right? So a small p-value will favor rejecting the null hypothesis. Okay. If you want to support a claim, write it as your null hypothesis. So remember, if our null hypothesis is our claim, we're not really finding evidence to support it. We're just looking to see if there's evidence that contradicts it. So if we were trying to support a particular claim, we'd want that to be our alternate hypothesis. Okay. Why can decreasing the probability of a type 1 error cause an increase in the probability of the type 2? Well, think of our justice system. It's the same thing. Type 1 error is where you reject the null and it's true. Okay. And in our justice system, that would be that we find somebody guilty who's actually innocent. Well, our justice system is designed so that that happens less frequently, right? It's a more egregious error to put an innocent person in jail. Look, we don't want to make either error, right? We're hoping that any jury is going to make the right decision. If somebody's guilty, they find them guilty, but we know that it's going to be possible. So if there's one that we're going to make more than the other, we're more going to be apt to have guilty people that get away. And the reason for that is that we have this assumption of innocence. The burden of proof is always on the prosecution, so we assume this person's innocent. We do the same thing with the null hypothesis, right? We assume the null hypothesis is true. So if we do that, decreasing alpha, okay, that if alpha is smaller, if there's a 5% chance of a type 1 error and we change it to 1%, well, that means we're going to be less likely to reject the null hypothesis. Well, if the null hypothesis is false, then we're going to be making a type 2 error in that case. So that's exactly what D is articulating here, right? A smaller alpha, a smaller chance of rejection, and if it needs to be rejected, we won't, which is a type 2 error. Okay. Why is the level of significance alpha equals 0 not? Okay, so remember, alpha is, if the p-value is less than 0, we reject the null. Well, that's impossible. So we can't possibly reject the null hypothesis. There's really no chance to, really no reason to do a hypothesis test in that situation. So remember what these significance levels mean, right? If the significance level is 5%, then that means we're going to reject that null hypothesis anytime we get a statistic that happens 5% of the time when it's true. Well, if we get something that happens 5% of the time, then surely something that happens 10% of the time is going to be significant as well. So when it says choose the correct answer below, yeah, the p-value, the claim would be rejected if the p-value is less than 0.05. That's a pretty concise way to say it. Then the p-value would be less than 0.1 as well. So I was having this conversation with one of the students just to try to oversimplify everything. If you're testing for mean, it's a t-test. If you're testing proportions, one proportion z-test. Okay, and then for the chi-squared variance, you're going to lean on StatCrunch. I'm hoping the questions I put on here you won't even need StatCrunch for. They're just going to be conceptual about when you would or wouldn't reject a null hypothesis. So let's see if the quiz me button's not going to bog us down for too long. Okay, 2 questions. T-test, right? State whether the standardized test statistic T indicates that you should reject the null hypothesis. So we can see our critical values are 1.477, negative 1.477. Anything that's in those blue areas will cause us to reject the null. So for letter A, negative 1.566, sure, he is in that blue region. He's less than that critical value, so we would reject. For the next one, 1.468, he lives here in this tan region. He's not going to be bigger than 1.477, so we would fail to reject it because he is in that beige region. What happens with 1.549? He's going to be in that blue tail to the right. So we would reject the null hypothesis because he is greater than 1.477. He's in that blue rejection region. And then negative 1.548, he lives in the blue rejection region as well. So we would reject the null because he's less than that critical value. Okay. So not too bad. This is what you're going to be looking at on the final exam as far as rejection region type questions. So should you fail to reject or reject the null? Again, same kind of question. Now it's just a left tail test. So the only way we're rejecting is if it lives below negative 2.005. So this certainly will be a fail to reject because he's bigger than negative 2.005. 0, we would fail to reject because he's larger than negative 2.055. Negative 1.995, same thing. Can't reject it because he's greater than that critical value. He needs to be in that blue area. And then finally, we get a winner where we can reject it because he lives below that critical value. I think we can submit. Oh, looks like we missed one of these. Maybe I just didn't read carefully enough. Oh, wait a second. 1.46. Oh, okay. Yeah, I read the wrong symbol. Wait, 1.468. Yeah, I thought I picked that one. Don't remember clicking that. I thought for sure I clicked on this. Maybe I inadvertently. You can go back and rewind the video and see, but I'm almost positive I picked that fail to reject because he's in that region. Oh well. So we had our hypothesis test for means. That's using the t-distribution, and now we also will have a hypothesis test for proportion. There's 5 questions in here, so we might skip some of these. It's going to be kind of lengthy. I do know you have one like this on the exam, so I'll make sure I walk you through this one. Education researcher claims that 61% of college students work year-round, right? So that is an equal claim, right? Simple, just 61% of college students work year-round. That's always saying there's no direction to that at all. So what would the null and alternate hypothesis be? The null is going to be our equal sign, that the proportion of college students that work year-round is 0.61, and then the alternate would just be that it's not 0.61. Okay. Our critical value, this is going to depend on our alpha level of 1%. So if my significance level is 1%, remember this is a 2-tail test, so that 1% is divided up into 2 tails. So it's not 1% in each tail, it's 0.005 in each tail. Okay, you have 99% in that interval between them. So the way I get my critical value, since it's a 2-tail test, we can do second bars and use inverse norm. Second bars. And number 3 is inverse norm. So remember, the area is the area to the left. So you're going to either use 0.005 or 0.995. And this will get us our critical value. So like I said, if I hit second enter here, I'll show you what I mean. The critical value is a plus or minus deal. If this was 0.995 and I wanted the right tail critical value, there's both of them, it gives me the same answer, just one's plus, one's minus. So 2.576, let's see how many decimal places they want. 2. So the 2 decimal places, that would be plus or minus 2.58, I think, right? Yeah, 2.576 will go up to 2.58, plus or minus. So what's the rejection region? Anything that lives out in those tails. Anything below negative 2.576, that's where he is. Anything above positive 2.576, that's where he is. Okay? Anything in there is where we're going to reject the null hypothesis. Rejection regions are below negative 2.58 and above, and above positive 2.58. Okay, so now we get our test statistic. So this will be our 1 proportion z-test. Here's our sample size of 400. 244 said they work year round. We want to see if that's significantly different from 61%. So we go to stat and test. And this is a 1 proportion z-test. So the claim proportion was 61%, 0.61. Oops. Okay, it says 0.61 or 0.61. Having trouble typing that in for some reason. And they had 244 out of 400. So we communicate that to the calculator. And this was a 2-tail test. We're just simply trying to figure out if it's different from that. Okay. So we get exactly 61%. So we get a z-score of 0 and a pretty high p-value. So it's not going to be significant evidence to reject that. So we get a statistic of 0. So it's definitely not in the rejection region. So we would fail to reject the null hypothesis. So when we don't reject a null, it's because there is not enough evidence to reject his claim. His claim was that it equals 61%, and we didn't have any evidence to the contrary of that. Okay, so this one's pretty much the same as the last one that we just did, right? 85 out of 340. Going to be pretty similar in the setup there. So I'm going to skip that one. We'll go ahead and just submit the quiz for now. Yep, we're fine. Okay, so question 1, we got 100% right. Every part of that was good to go there. Let's get back to the study plan. So I want the study plan for my final exam. And now we'll take a peek at the chi-square questions. Again, I try to keep these pretty simple. Some folks are saying on test 3 they couldn't get StatCrunch. It should only give you StatCrunch if you need it. Okay. So here all we're asking is, do we reject a null or fail to reject a null based on these values? So here's my critical value, 21.06. I need to be in the blue region. 16.715 is not. So it's not in the rejection region. So make sure you read that carefully. You're not rejecting it because it's not in the rejection region. Okay, chi-squared equals 0. Certainly also not in the rejection region, so we don't reject the null. C, chi-squared 1.323. Again, not in the rejection region, so we do not reject. And then 21.152 barely gets in there, but we would reject the null hypothesis because the test statistic is indeed in that rejection region. And same thing again, now we just have 2 tails, okay? So 19.805, where's he? He's in here. He's not in the blue region. He doesn't make it there, so we're not going to reject the null hypothesis because his value is not in the rejection region. Stay on that. 19.819. 819 barely gets in there, but 819 is in there, so we reject the null hypothesis because that statistic does land in that rejection region. 7.049. Got to go all the way to the third decimal place and see. It's going to be a little bit to the right. It's going to be in the white area. So we do not reject the null hypothesis because he's not in the rejection region. 7.035 though, he falls just below into the blue. So we would reject the null because he lives in that rejection region. We can submit our quiz. Okay, so I think between both videos now that we have posted here, you have a pretty thorough review of what you're going to see on the final exam. So for the folks that need it, I really hope it's helpful to you. It's been a crazy semester for everybody, so hopefully this is something that will help you out.